Hello friends, now in this video I will be taking relationship of NPV with IRR. We have already done these two methods, NPV and IRR, and we have also discussed some part of relationship. But now I will be taking it in detail with numerical example, very important from exam point of view, because in MCQ we may get situation of similarities of between NPV and IRR. We may get situation where NPV and IRR are giving conflicting results, and we may be asked to create an NPV profile that which out of two projects, which project is preferable at what level of required rate and when the alternate will be preferable. So we have numerical illustrations for this. We will go for that. So let's start. So what we have already done, we have already done two LOS, describe type of capital investment. We have discussed four capital investment, going concern or maintenance projects, regulatory requirement projects, expansion in the same field or same supply chain, and the new projects, new line of business, new geography, new technology, most riskiest project. Next, we have already covered LOS2, that is describe of capital allocation, describe the steps of capital allocation process, idea generation where SWOT analysis will be done. Idea may come from any source, internal or external. Then investment analysis is the second step where we have used three methods, NPV and IRR in case project specific data is available, which is generally available with management, and if you are doing it from analyst point of view, research analyst point of view, who is not having access to individual project data, then the available data will be used, that is the consolidated financial statement. So generally the work will be done on the aggregate basis when we are going to use return on invested capital. Then contrast their use in capital allocation. That is what I am going to take today in very detail. So contrast means you have to compare. What are the, and when we are comparing, we have to understand what are the similarities and what are the differences. And then we will finally decide which method is preferable under what circumstance. So let's start with today's topic. So relationship comparison between NPV and IRR. When I say comparison between NPV and IRR, let's first understand the similarities. Similarities are very easy. First thing, both techniques are based on time value of money. So both are using discounting concept. All future cash flows in both the techniques are getting discounted by rate. In case of NPV by COC, in case of IRR by IRR rate. And then all the future cash inflows are brought to the T0 level, that is the point where decision is taken, and that value is called as PVCI, present value of cash inflow. And then it will be compared with PVCO, that is present value of cash outflow. In case of NPV working, the discounting is done by cost of capital or required rate of return, and this may give three results, positive, or it may give zero, or it may give negative result depending on the value of COC. When the inflows are discounted by IRR, which is the implicit rate of return inbuilt in the cash flow what project is generating. So if you have extracted the return, what is left is the principal invested in the business. So when you are discounting all future cash inflows at IRR, the summation is equals to PVCO. So when you are comparing with PVCO, it is going to give a zero net value. These are the conditions we have already done. So two similarities, both are considering the time value of money, and both are considering the entire cash flow stream over the complete life of the project. So if we want to create a mathematical relationship between NPV and IRR, and these are the most probable questions in the exam, at this level of NPV, what is the situation of IRR, or at this level of IRR, what is the situation of NPV? So three relationship. Second is very clear. So if we use these two equations, NPV equals to PVCI at the rate COC minus PVCO, and at IRR, PVCI at the rate IRR minus PVCO should be equals to 0. And in case of NPV, it can be positive, 0, as well as negative. If COC and IRR are same, the required rate of return, what is NPV? This is your PVCO, the example what we have used in case of calculation of NPV. is PVCO, the empty cone given by investor invested in the project. They want to fill it with ice cream. That is the required rate of return, cost of capital. So if your project is generating implicit rate of return inbuilt in the cash flow, what project is generating is equals to IRR. And this IRR is if equals to COC, so there will be no excess return which is represented by NPV. If both these two are equal, of course, NPV, because if you are discounting by COC and COC is equals to IRR, so of course the PVCI will become equals to PVCO, so your NPV will be zero, but still the project is acceptable. Why? Because at least you are generating that much what investor or the organization is requiring from the project. So in both in this case where COC is equals to IRR and NPV is equals to zero, you are going to invest in the project. Let's go for second case. If IRR is more than your COC, required rate of return. If IRR is more than your required rate of return, it means the inbuilt return in the project's future cash flow are more than the required return. So when you are going to discount it by COC, which is a lower rate than IRR, the present values will be higher. Present value of cash flow, cash inflows will be higher. We know that the relationship between discounting rate and present value is inverse. So if your COC is less than IRR and at IRR your NPV should be zero. At IRR, if you discount, it should be equals to PVCO. Your cash inflows should be equals to PVCI should be equals to PVCO. So if you are discounting it by a lower rate, which is COC, of course your present values will be higher. So if your IRR is greater than your COC, this present value of cash inflow will be higher than your PVCO. So if it is higher than your PVCO, then your NPV will be positive, and in this case again you are going to invest. Next case, it means that the investor is asking 10%, and if your project is generating 12%, of course it is going to generate excess return, and that excess return is your NPV. Last case, if your IRR of the project is less than your COC, and if your IRR is less than your COC, and if you discount it by COC, which is a higher rate, so your PVCI will be lower than your PVCO. Because if, let's say, investor is asking 10%, but project is generating 8%. So at 8%, your PVCI and PVCO are equal. But if you discount it by 10%, your PVCI will go down. So at PVCO is higher than your PVCI at COC. So it means your NPV will be negative and you should not be investing in the project. So generally 99.99% the result of NPV and IRR will be same, where IRR is greater than COC because COC represent your hurdle rate, cost of capital represent your hurdle rate, required rate. So if your IRR is greater than your required rate, hurdle rate, you are accepting. NPV is positive, you are accepting. If IRR is less than COC, hurdle rate, then you are rejecting. Your NPV is also coming negative, you are rejecting. But in some cases, some exceptional cases, these two methods may give different conclusions. Different conclusion in some situation. And what are these situations? There might be, so in case of individual project, only single project, there will be never a situation where NPV says accept the project and IRR says reject the project. No. Even in case of independent projects where you can select multiple projects at a time. So if NPV says that you should invest in project A, B and D, not in C, IRR will also say that you should invest in A, B and D, not in C. So in case of independent multiple projects also, there will be no conflict. Only in case of multiple projects with mutually exclusive condition, And even in that scenario, only in few situations where numbers are following certain pattern, there might be, not always, certain mutually exclusive project where NPV and IRR will reach different conclusions. And what are these three situations? Number one, size and scale disparity. When I say size and scale disparity, I have created an example illustration A. So we have COC of 12%, that is your hurdle rate. There are two machines, we have to select one. One is having a outflow of 1 million, second is having outflow of 1.5 million. Both are having almost equal life. First is having 5 years, second is having 6 years. But second's outflow size of outflow is much higher, almost 50% higher than the machine one. Cash inflows are also higher in this case. So if I calculate my NPV, first case 1 million CF, how many cash flows? 301, 500. Value of cash flow for 5 years. 12 is my COC. What is my NPV? 86, 840 visible. What is the IRR? 15.45. In same order, I have calculated for machine 2. Machine 2 CF 1500 000 393 500, 6 years, NPV 117, 839 and IRR is 14.73. So if these two projects are machine 1 and machine 2 are mutually exclusive, we have to get only one machine. If we decide based on NPV, we will select machine second. If we decide based on IRR, we will select machine 1. So there is a conflicting situation. So, and this situation is arising only in case of mutually exclusive situation, because if these are independent projects, both are giving positive NPV, we will select both the projects. But only one is required to be selected. So here there is a conflict. And this situation is called as size and scale disparity. Second, disparity in life of proposals. Here also there is a difference, but very minor. Illustration B, COC is 15%. Project A and B, project A require 40,000, B require 20,000. Again, the size is also different. Project A is generating cash inflows for 6 years. Here again, we are going to use CF function. 40,000 negative, CF 0. 1 is 13,000. Frequency 1, 8,000. Frequency again 1. 14,000, again frequency 1, 12,000, again frequency 1, 11,000, and again frequency 1, and then 15,000. All cash flows are in. 15 is my discounting rate. So NPV is 5374, and what is the IRR? IRR is 19.73. Same fashion we can calculate for project B. Again, if we select, if it is a mutually independent situation, we will select both the project because both are yielding higher IRR than hurdle rate and both are generating a positive NPV, no problem. But if it is a mutually exclusive situation, NPV method will select project A, will recommend project A, whereas IRR will recommend project B. Again, conflict. Why there is a conflict? Mutually exclusive scenario and huge disparity between the life of the project. Let's go for the third case. Third case is difference in timing and amount of net cash flows. Timing means pattern. So again, illustration C, 10% COC, and now this life of project is same 5 year. PVCO is also same 500. But if you see the pattern of cash flow, this project X is giving a ascending order, whereas Y is giving descending order of cash inflow. And again, in the same using CF function, if I calculate NPV, both are giving positive NPV. Independent situation, both will be selected. IRR in both cases is higher than your COC, cost of capital, your required rate. But if it is a mutually exclusive case, you will select X with the use of NPV and you will select Y with the use of IRR. So there are situations of conflict. So which method should be preferred in this case? Project D, I will take next. This will cover the creation of NPV profile if COC is not given. Why there are reasons for difference means which method we should be using For selection of project in case of mutually exclusive situation where conflicting decisions are coming. Always conflicting decisions will come? No, that is not true. But in these three cases, there are situations. And why this is coming? The reason which is superior is the reason is the inbuilt assumption in these two methods. When that we have already covered in the last video, again I am repeating it. When you are discounting, when you are calculating NPV, what you are doing, you are discounting 1 plus COC, your required rate. CF2 1 plus COC, your required rate again till CFNth 1 plus COC and minus your cash outflow, which is a negative number. Effectively, what if I take LCM? It is CF1. Let's say it's a 4-year cash project. So CF1 will be compounded for 1 plus COC power 3. CF2 will be compounded for 1 plus COC power 2. And the last one, CF4, will be not compounded at all. Minus your CF0 1 plus COC power 4. And this is your NPV 1 plus COC power 4. Final return will be received at the end of 4th year, not at T0. We do calculation at T0, but actually the returns comes at T4, the last day when the project will complete. So from here to here, it represents the present future value of cash flows, inflows, compounded at required rate of return. And why it is required rate of return? Because for an investor or organization who is investing in this project, they must be getting this required rate of return at some other source with the some other alternative investment with the same risk profile. So if I am getting 15% in other alternative investment and I want to invest in this project which is of same risk profile, I should be getting 15%. It means this 15% is available in the market. It is economically realistic to assume that if you are having any intermediate inflow CF1, CF2, you will be able to invest in the market at the future point of time at this particular rate which is available in the market. And this is your future value of outflow. And this is the net returns at maturity, at completion. So here in case of NPV, the assumption is that intermediate cash flows are reinvested as COC, required rate. When I am calculating IRR, what I am doing? I am discounting PVC cash inflows at IRR and I am comparing it with PVCO and it should give 0. So what effectively we have done? CF1 upon 1 plus IRR power 1 till CF4 1 plus IRR power 4 minus CF0 should be equals to 0. So if I compound it, I will get CF1 1 plus IRR, the return which project is generating. Are we going to get the same return in the market at T1 where we will be receiving CF1 for additional investment period of 3 years? CF2 to be compounded by IRR for additional 2 years. And last CF4 minus CF0 1 plus IRR power 4 should be equals to 0. 0 multiplied by that cross multiplication will again give 0. If we see this positive value, these are present future value of cash inflows compounded at IRR rate. Are we going to get other similar projects at T1 for investing the inflow coming from this project? May not happen. Not sure. So which assumption is more realistic, economically feasible? To assume that intermediate cash flows will be reinvested at COC or intermediate cash flows will be reinvested at the return what project is also giving? COC is the better choice. That is why NPV is treated as superior than IRR. So whenever there is a conflict between conflict in the decision by NPV and IRR, we use NPV method. So, and this particular assumption is called as reinvestment assumption, and we have already done. And even in case of unconventional cash flows, where cash flow is changing sign again and again, means multiple outflows and multiple inflows are coming. Year T0, outflow 1 positive, or outflow again second positive negative, third again positive negative. If these are the situation, NPV will always generate a single value absolute in currency terms, whereas here there is a problem of IRR. Multiple IRR may come, and when there are multiple IRR, again there is a problem. This required rate, hurdle rate, to be compared with which IRR, IRR first or IRR 2. IRR 1 may say select, IRR 2 may say reject. So that is why whenever there is a conflict, we always go for NPV. So next is NPV profile, very important exam point of view. Now we are given two projects, project illustration D, very important. P and Q, both are of same COC, cash outflow 100. Right now I am giving COC, but this COC we will use for comparing. And both are having a tenure of 4 years. Project P is generating 36 million rupees, thousand, whatever you may say, 36 for 4 years. Whereas project Q is only giving 175 at the end of 4th year. So if I calculate with this COC of 10%, with this COC of 10%, 100 negative, 36, 4 frequency, 10, NPV is coming 14.11 and IRR is 16.3675. Next project, 100 negative, 0 is coming for 3 times, frequency 3 and 175. Again 10, NPV 19.52 and IRR is 15.01. Done. Again there is a problem. If COC is given, again NPV of Q is higher and NPV of Q is higher. Q is higher, whereas IRR of P is higher. Given the fact that COC is available and both projects are giving positive NPV, both are giving IRR more than COC. After understanding the reinvestment assumption problem, we will select project Q because it is generating higher NPV. We will ignore IRR in this case. Now let's take a situation where COC is not available. Cost of capital, required rate is not available. And question asks us, which project will be always acceptable or in which range of required rate? So if COC is not available, we cannot calculate NPV. We cannot calculate NPV. But the pattern of these two projects, we can compare. How? Both are having equal PVCO, 100. So when deciding, this PVCO can be ignored because both are having an equal outlay. Both are of equal tenure, 4 years. So again, timing is not the issue. So which project will be accepted? We will go for the range. If COC is not there, IRR, still IRR we can calculate. So we are having IRR of 16.3675, IRR of 14.0163. We are not having NPV now. This data we will not be able to calculate without the information of COC. IRR is possible. Assuming that COC is 0, required rate of return is 0. Assuming. Theoretically, project P is giving us 36 for 4 times, means total is 72 and 72, 144 at an outlay of 100. So overall return is 44 rupees. No discounting. So 36 upon 1 plus 0 power 1 is 36. 36 upon 1 plus 0 power 2 is again 36 because 1 plus 0 power 2 is again 1. So 36 upon 1 is 36. And last 36 upon 1 plus 0 power 4 is again 1 plus 0 because required rate of return theoretically if I assume 0, 1 plus 0 power 4 is again 1. So 36 upon 1 is 36. So I at 0 discounting rate, if I create a chart at 0 discounting rate, my NPV of project P, blue line, will start at a point of 44 rupees. And in case of project QA at a 0 value of required rate, so 175 upon 1.0 power 4 is again 175 minus 100 is going to give a NPV of 75. So the green line, which is the project Q, it will start from 75. Now we have IRR, and at IRR NPV should be 0. So we got the two coordinates. We got two coordinates, project Q, two coordinates are, coordinates means I am saying your discounting rate, comma, NPV. So for project Q, it is for discounting rate 0, it is 75, and for discounting rate, how much? 15.0163, comma, it is going to give us 0 NPV, 0 NPV. So at 0 discounting rate, 75 is NPV. At 15.0163, 0 will be the NPV. Same with project P. With 0 discounting rate, NPV will be 44. And with the 16.3675 discounting rate, NPV will become 0. Using these two coordinates, we can draw line on this NPV discounting rate and NPV chart graph, and we can create a NPV profile. And we got a point where these two lines are intersecting. These two lines are intersecting. This will happen whenever there is a conflict between NPV and IRR. If NPV and IRR are giving exact similar results every time, it means one is always superior than other. So there will be no conflict. Conflict will always arise whenever these two lines will intersect. And from the number, we have arrived at the conclusion that yes, NPV and IRR are giving conflicting situation. Even though NPV is not available, even though this NPV is not available, by drawing the diagram, these lines on this NPV and required rate graph, if there is an intersection of these two lines, these two NPV profiles of these two projects, it means there is a conflict. Now, which project is preferable at what required rate? So let's find out the intersection point, coordinates of intersection point. Now, how we are going to find out the coordinates of intersection point? The coordinate of intersection point will satisfy equation of both the lines. And this is a line. What are the equation? NPV of P is equals to PVCI of P minus PVCO of P. And NPV of Q is equals to PVCI of Q minus PVCO of Q. At intersection point, these two lines coordinate should satisfy these two lines. That means the NPV should be same. So if I want to equate my NPV P with NPV Q, your PVCI at P minus PVCO of P should be equals to PVCI of Q minus PVCO of Q. And in this case, both the projects are having same PVCO, so they will cancel out. So now what we are left with? We are left with PVCI of P should be equals to PVCI of Q, or PVCI of P minus PVCI of Q should be giving 0. Now we do not have rate at which these two will generate. That's what we are trying to identify. So let's assume the intersection point rate is X%. This is your X%, the intersection point rate. This will give 36 upon 1 plus x to the power 1 plus 36 upon 1 plus x to the power 4 minus 175 upon 1 plus x to the power 4 equals to 0. And this is the situation of NUT versus a single cash flow, which is very easy to calculate in our calculator. Let's put 36 as PMT, positive, for 4 periods, and at the 4th period end, 175 should be the negative value. PV is 0, calculate the IY, it is giving a X% equals to 13.1594%. It means at this point, 13.1594 coordinate of x-axis, these two lines are intersecting. Now we can calculate NPV also. Now we can calculate NPV of this project. Which project we have in this? Okay, now this, let's calculate 13.1594. If I input this, I got an NPV of 6.7273. 6.7273. Let me put the values of first quad project also. Second clear, 100 minus 36 for 4 times. The discounting rate is 13.1594. NPV is again 6.7273. So at this point of 13.1593, both projects will give equal NPV. But looking at the lines, now we can conclude that the project which is going to generate higher NPV is the preferable. So this line is preferable below 13.1594, and blue line is preferable above 13.594. The blue line represent your project P, and below this project Q. Now let's put the numbers of actual NPV which we have calculated at 10%, which is less than this 13% indifference point NPV. Indifference point, I'll say. In this case, the project P will give a, let's put the perpendicular from 10% and then the reverse perpendicular on y-axis. So project P, which is blue line, is giving 14.12, and project Q, which is green line, is giving 19.54, and 19.54 is higher. And even in our situation also, we were selecting this project Q because it is giving a higher NPV. But this project is acceptable only if COC is 10%. And if COC is not available, then what we will say, if the required rate of return, if the required rate is less than 13.1594, select the project. Which one? Project Q. If the required rate is equals to this, any of two, indifference. And if the required rate is greater than this, NPV will change. You will select project P. Still, we are not making decision based on IRR. IRR is used only to create coordinates of line, to create a line. But IRR is not the base for decision making. So hopefully everyone understood similarities of NPV and IRR, conflicting situation of NPV IRR, and creating the NPV profile. Now the situation, they may ask you, at what required rate of return project P will give excess NPV of 10, excess NPV of 10. Very easy, same equation, project P is giving excess NPV of 10. So project P NPV should be equals to project Q NPV plus 10. We will add here 10 extra and we will solve this equation again. This is possible in this particular type of illustration because PVCO is same and life is same. In case PVCO is different, in case life is different. situation, and most important, the pattern of cash flow is different. Here I have considered a specific pattern where one project is giving an annuity cash flow and second project is giving a single cash flow. What will happen if rather than annuity cash flow these are unequal cash flows, or rather than project Q single cash flow there are multiple cash flow? Then we have to do complete trial and error, hit and trial method. We have to do check at different points to arrive at that indifference point of these two lines. That will be a bit complex, because if PVCO is different, these will not cancel out. These values will not cancel out. They will also stay in the equation. That is okay. That means let's say the PVCO of 10, P is 90, whereas PVCO of Q is 100. So P is going to generate an additional NPV of 10 because its outflow is lower. So PVCO will be also considered here. The only problem is when these are unequal cash flows, then you cannot use direct that TVM keys of PV, PMT and IY. You have to do hit and trial. But when these two lines will intersect, only the situation where NPV and IRR are having conflicting results. Hopefully everyone understood this. Let's close this. Next we will take another theory topic, and then next topic real options. Thank you so much.